Hello, everyone. I'm Adam from Aleph Zero. We're working on layer 1 with privacy framework. Today, I'm going to talk about ZK ID in the context of DeFi. So ZK ID stands for zero knowledge identity, and it connects two seemingly opposite concepts. So zero knowledge, as some of you may know, is all about anonymity and privacy, while identity, especially on-chain identity, is all about accountability, traceability, and connecting all the actions to one user. So before I actually delve into how to connect these two opposite terms, maybe one comment on anonymity on blockchain. Many people think that blockchains by default are private or anonymous. So this is by far not true. And pretty common problem is that whenever I, as an account owner, transact or interact with another party, this party is able to backtrack my transaction and see my entire transaction history. So, provided that I'm actually using my account to buy things, well, it's a bit like with browser history. So, my transaction history doesn't need to be illegal to be sensitive. I mean, definitely there are things there which I wouldn't like to reveal to the open public. And this is what happens by default on blockchains. Everything is public and everything is revealed to the open public. So not only Bob here, with which I interacted with, sees everything, but also all the evil actors of the world can see everything. One may think that, well, we can create another account, but actually it's not so hard to see through such actions, and there are even companies which are specializing in backtracking such patterns. So what many people do is that whenever they want to interact with a new party, what they do, they use centralized exchange as kind of a mixer. So they are sending tokens to centralized exchange, and then they are sending in somewhere from this centralized exchange. So the goal here is that, well, it's not really possible to backtrack it anymore, because this address of centralized exchange possibly has dozens of millions of dollars in it, and acts on behalf of thousands of users. So yes, this effectively, well, at least achieves this thing that it's not public to everyone what I'm doing. It's still, of course, possible to see by owners of this particular exchange, but it's still a bit better. Although, obviously, a problem here is that while we are living in this decentralized world, we're trying to build the decentralized systems, and now, out of a sudden, the only privacy we can get is through centralized exchanges, which is, well, not what we've been fighting for. So what people are doing is replacing the centralized exchanges by cryptography. So, in particular, ZK SNARKs, this is the buzzword many of you possibly have seen already. The idea here is that this acts as a trusted third party, but actually there is no manager there. This is just pure cryptography. I'm not gonna go deeper into that because of the time constraints. What I want to comment on, though, is that this is actually a bit too good. It gives a bit too much privacy, in the sense that, well, it's often abused. So the history shows that this is by far the favorite financial instrument by hackers and other illicit actors. So majority of blockchain hacks share the same story. Someone steals the funds, and then these funds end on a crypto mixer, and then the trace is effectively lost, and there is literally no mathematical way of backtracking it, which is bad. So one thing is that it's, of course, bad that the illicit funds are getting mixed, but the other thing which is also bad is that, the chain analysis claims that 23% of funds sent to mixers are illicit, but, well, the remaining 77% of users are also affected by sanctions, which, well, is also kind of bad thing. So what we're trying to do in Aleph Zero and what ZK ID is all about in the context, at least, of blockchain actions, is solving this problem. So making such an anonymity pool that will somehow ban hackers from it. So in a moment, I'm going to show how in theory it's possible. But first, what is blockchain ID in general? So the pattern, like for general blockchain ID, is as follows. Alice can show some documents or face or some other information to a trusted provider. Then this trusted provider mints some kind of ID token to Alice, which resides on her wallet from then on. Then, for example, whenever she interacts with some decentralized exchange, this exchange can request her to check her ID. So because maybe it's exchange which does not accept some kind of users. So she needs to be verified that her ID is good enough to use this particular contract. And after it is verified, the trade is executed. There are two ways you can think about it. One is that this ID can be transferable between accounts. In some cases it makes sense. In some cases it does not. And there is also a concept of soul-bound ID, which is forever bound to account. So in all practical aspects, it's forever bound to a specific person. Accounts are rather not transferred between people because it's hard to transfer private key. So what is blockchain ZK ID then? It's actually pretty similar. But the core difference is that much less things are visible on chain. So that's why we call it zero knowledge. So again, Alice shows some documents to the trusted party, but right now, the trusted party does not publicly mint token. What happens instead is the trusted party establishes a secret ID with Alice. So now, when Alice wants to use some financial instrument which is not for everyone, which requires some specific identification, this identification happens in zero knowledge, which means that she is able to cryptographically prove only the thing that she is allowed to use this exchange or this particular financial instrument. No information over that is ever leaked. So she provides this clever cryptographic proof to the DEX, and then after the proof is verified, she is able to interact with it as an accepted user. So what are the properties of it? So first, Alice transaction origin is unidentifiable, meaning that well, provided that she was keeping some kind of address hygiene, the ID system itself does not reveal any additional information than what would be revealed without it. So, so the privacy is not sacrificed because of this additional requirements. The other thing, Alice can do it from any of her accounts. That's because we do not have any specific token which is account bound right now. What we have instead is Alice, which knows some information, and she has an ability of creating these proofs. And she can create this proof from any address she wants. These proofs are things she computes on her machine, and hence she can attach them to a transaction originating from any particular address. This is also very good from the privacy perspective, because Alice can freely change between addresses, and for any of these addresses she can use the same true identity of herself for any practical reason. And what's very important here is that if the transaction is later found to be fraudulent, the KYC provider can link it to Alice afterwards. So the system has the property that there is this specific actor, which is the KYC provider, which actually can track Alice transactions. The provider does not do it on a daily basis, although whenever there is a specific transaction which is seemingly fraudulent, a KYC provider can look into it, can see what ID was attached to it, and can identify all the trace of this particular transaction. So this is the first iteration of the system that we're building. This is a very sensitive component, this decision factor. So who we want to reveal and who we do not want to reveal. So initially, we're thinking about it in a way that there will be a single KYC provider that will be deciding based on court judgments which transactions needs to be revealed, and which not. In the further iterations, we're planning to have a DAO of different KYC providers, and the consensus on the decision will be required to reveal any transaction. Thank you. That concludes the presentation. If there are any questions, I think I should have a couple of minutes. Can we support the question?
Anybody have any questions? Okay.
The first version, does it seem super centralized for having something very private? I mean, you have like a single point of failure, which is your KYC. Then why I want to hide my identity since that guy knows everything about me?
Yeah, so that's true. It's centralized in this sense, although what we're replacing is the system where entire world can see everything about you. With a system where there is a single provider which can see these things about you. The provider we're working with already supports almost 1 million users, and it never revealed anyone because it never got a court claim. So I do agree that this version is suboptimal and as it's centralized, but it's still significantly better than what is meant to replace.
Hello.
Hello.
Sorry, my name is Aina. So, if the Lazarus group could hack those bridges, they can also hack this centralized place where all these IDs are stored?
Well, of course. I mean, everything can be hacked. The thing is that bridges are hacked because a lot of tokens are stored in the bridges. So they are hacked for economical reasons because, well, bridges are contracts which traditionally store the most value inside. So right now, like with this system in place, in order to hack a bridge and escape with the funds, you need to hack two things already. You need to hack bridge, and on top of that, you need to hack this anonymizer. So, well, I'm not gonna claim that this is unhackable. Everything is hackable to some extent. The thing is about the costs. So hacking two independent systems is obviously significantly harder than hacking a single system. And yeah, I guess that's the best answer I could give.
One more question?
And maybe on top of that, hacking just this system without stealing any funds doesn't bring you any value because, well, you don't have stolen funds to anonymize. So, like, indeed, you actually need to hack two systems in order to get away with it.
Hello. Thank you so much for what you're doing, first of all. And second of all, what is the main difference with the Polygon supernets, for instance? Because as far as I know, this is one of the best shard chain IDs solution.
Yeah, so we are obviously not the only ones building system like that. From the top of my head, I'm not sure what's the decision process in Polygon for revealing stuff. Yeah, I'm sorry. I just don't know from the top of my head the Polygon solution deep enough. But I assume that. Yeah, so sorry. I'm just not sure.
Okay, sorry, for this question. But do you do any research with competitors?
Yeah, obviously we do. Right now, the solution that we see as most similar is actually not Polygon, but
Avalanche?
Sorry?
Avalanche or Near?
I mean, these are the layer ones. What we're usually researching are the privacy systems. So things like, for example, Railgun on Ethereum, or like we do a lot of things when it comes to private DeFi. So projects as Penumbra on Cosmos also. Yeah, Alio have a very similar framework when it comes to privacy to us. So yeah, we of course do competitive research. Just like when it comes to the specific item of Polygon, I'm sorry, from the top of my head, I cannot answer that.
Okay, great. Thank you so much.
Thank you very much.